All right, for everyone who just joined in, we're going to be starting, like always, like in a few minutes, just to let some last people come in. And yeah, just to let some last people come in. People were coming in late, just to let them come in. And so we're going to start around 12:04 ish. That's around when we're going to start. All right. I guess we'll have the slides and the recordings available for you guys to view after the presentation is over. So to get started with our topic for today, so our topic for today kind of continues off of what we did yesterday. So yesterday we looked at some like basic Unix commands, and today we're going to be looking at the Unix and shell scripting. So the shell as sort of a place to like manipulate text. So basically, what we're going to be talking about first is sort of what the shell is. Like, what is the shell? We hear about the shell a lot. We're talking about shell commands or a bash shell or a git shell or something like that. You often hear about the shell, but what is the shell? And so the shell, or the it can be Windows, Unix, Linux. It's where the commands can be run. And a shell procedure is what we're going to be talking about today. And it's basically a file which contains shell commands. So a shell procedure is basically a program for the shell. It runs shell commands in it. And so a very simple procedure. Okay, wait 1 second. I'm going to refresh my page and see if that fixes it cutting out and off, because I feel like it's cutting out and off for me as well. So give me a second. This should this should work. Let me know. Let you guys know if this is working a little bit better in terms of like my audio cutting on and off. Oh, I forgot. It's like there's a bit of a delay, but yeah. Let me see. Let me know if this one is working out a little bit better. Because I think it was giving me notifications about bad connection as well before. If you guys can just like let me know in the chat, and then we'll see from there if this. Yeah, I think it's working better now because I'm not getting the bad connection sign on my screen. Okay, thank you. All right, so I'm going to continue with this. So, like I was saying before, what the shell is basically a place where you can run commands, and a shell procedure, which is what we're going to be talking about today, is basically a file which contains commands. It's a program for the shell, and a very simple shell procedure is like what we discussed yesterday, where you can just run echo and it echoes and it prints out whatever you want into the prompt. So with just like with any other programming languages, there's also variables. There's in the shell they're called shell variables, and it gives you the capability to define a named variable and assign a value to it. The simplest way of setting a shell variable is via what's called an assignment statement, which sounds kind of complicated, but it's basically saying variable equals value. So you can say x equals 2, or a equals 5, or string equals hello. Like it's just as simple as that. And the value assigned to the variable can then be received by preceding the name of the variable with a dollar sign. So if you say variable equals 2, then you can't just say variable and expect to get the value back. You have to put a dollar sign before every variable, and then that'll give you the value. So that's one important syntax to remember is if you ever want to access the value of a variable, let's say you do x equals 2, and you want to print that out, you have to do echo dollar $x in order to get the actual value of it. And so just like I said before, setting command values to variables in the shell, let's say you have like now, the variable now is equal to IAmTest, and you want to print IAmTest. You do echo dollar $now, and it'll print the value of that. And you can actually, later on when we talk about like shell procedures, there's going to be certain arguments that you want to pass in. Like let's say you want to pass in a number and a text and I don't know, like another number. Then you can actually pass in arguments by putting them after the script name. So this is you have 3 variables. You have AAA, BBB, CCC, and DDD. And you have those, you reference those in your program. You can actually call whatever script name you have and then put AAA, BBB, CCC, DDD. Like put the variables after it and it automatically assign them to the individual ones, like argument 1, 2, 3, 4, and so on and so forth. So the next command that we're going to talk about that helps with basic shell programming is the expression command, the expr. So what expr lets you do is it lets you do mathematical calculations. You can't do 1 plus 1 on the command line and expect it to work. That's not how the shell programming works. You have to actually use the expr along with like the plus, the minus, the star, the asterisk, the divide, and the remainder symbol. So if you want to do 10 plus 11 plus 11 plus 2 plus 60 plus 1, this is like kind of, if you just want to do some basic addition. Instead of just typing 10 plus 11 plus 11 plus so on plus so forth, and hoping you get 95 out. You have to type expr and then whatever you want, and then that's how you get the result. So each value and each operator to be operated on forms a separate argument to expr. So there's no spaces between everything. So there are spaces between everything. So like I said before, in the previous slide at the bottom, when you're passing in arguments to shell procedures, there has to be spaces between them. So when you're working with expr, you have to put spaces between each one of the arguments so that it forms, because each one of them are separate when you're passing it to expr. And for certain arguments like the asterisk for multiplication, you have to escape it. So you have to do either \* or put star in quotes or put star in double quotes or single quotes. So you can't just do star. That will mess it up. You have to actually escape that character. So another example is, let's say you have num1 is equal to 2 and num2 is equal to 4. You can actually set another variable equal to expr num1 plus num2. So there's a lot of things going on this line. So first of all, you can assign a variable to a shell command. And what that lets you, and in order to actually do that, you don't put quotes around it. You don't put single quotes, double quotes, or apostrophes. You have to put what's called the grave symbol. It should be right below or right above your escape key, that symbol, the one with a tilde on it as well. So you have to actually put grave symbols both before and after it in order to put shell expressions when you want to do that in variables. And another thing you have to notice is they didn't just say expr num1 plus num2. They did expr $num1 plus $num2, because that actually gets the actual value of it, the 2 and the 4, and then that'll return you 6. Another important command when dealing with shell programming is what's called the test command. The test command is basically, it's not part of the shell, but it's intended for use inside shell procedures. So it's not something like a command you necessarily run. It's not necessarily a command you run in the shell, but it's a command you run inside of shell procedures, inside of shell programs. And the arguments to test form an expression. So if the expression is true, the test returns a 0. If the test fails, the command returns a non-zero value. And you can do 3 main sorts of tests. You can do tests on numerical values, tests on file types, and tests on character strings. So we're going to be going over this, and we're going to be going over what these tests do in a little bit. So I think we want to test for numerical values. If you want to test for numerical values, then let's say here you have cat file1. So let's say this is file 1. You have if test $1 minus GE. So with test, there's actually a lot of different tests you can do with numerical values. You can do -EQ to see if one number equals another, -NE for seeing if they're not equal, -GT for seeing if one number is greater than another, -LT for seeing if they're less than another, -GE and -LE for greater than or equal and less than or equal. So you can't just use the symbols that you're usually used to. You have to actually use these sort of test arguments here. So let's say you want to do cat file 1. This is one of your shell files. It says if test $1 is greater than or equal to 0, then it's positive, else it's negative. So then it'd be file 1 2000, the argument would be positive, and file 1 -871, the argument would be negative. So another one here is looking at the number of users that are logged on. So if you say users equals this command, see if you escape it with grace, it actually runs this command in the shell, and it gets you the list of how many users there are. So if the number of users is greater than 8, then you can say that more than 8 people logged on. And the same thing with this last program, which is another example of saying, is the number of words in this file where the number of words of that file, or are they the same? If they're the same, then this and that do not match, or they do match. Another test you can do is with is with what's called file type testing. So file type testing lets you do -s, which lets you check that the file exists and it's not empty. -f sees that a file is an ordinary file, not a directory. So it checks, is it a file or is it a folder? -d checks whether a file is really a directory, so is it a folder or is it just a normal file? -w checks that a file is writable, and -r that checks that a file is readable. So writable means that you can actually edit it, while readable means you can just see what the contents are. So if you can like have a file that you test, like, oh, is this not in a directory? Then if it's not a directory, then it returns not a directory, else it says it is a directory. And if you see here, like right here, it says if test not -d $1. So this is important, and it's going to show up in a lot of the different programs that we do after this. So test is like obviously the command you run, and not -d. So test is test not a directory. So if is it not a directory? And what $1 is it's not referring to like the variable one, but it's referring to the first argument that you pass in. Because remember we said you can pass in arguments to shell programs. So the first argument that you pass in, so say you do file1 of string.txt. So then that file is going to be the first argument. That's what $1 is. And it'll test, is that first argument you passed in a directory or is it not? And it'll print that out. And it's the same thing with this down here. You can test to see, does this file exist or does this file not exist? And you can actually do shell programs like that. Another test you can do is with what's called character strings. So with character strings, you don't do -eq. So with integers, you do -eq to test if they're equal, but with character strings, you just do equal or not equal. So you can check where the first argument is a 0 length string. You can say if test not -n, and that's over here you can see -n, check to see if it's a non-zero length, or check to see if it has a 0 length, is -n, and $1 is the first argument you passed in. Then echo you must give a file name, or the file name must have a length. And then same thing here, use the equal sign instead of -eq. When you combine test with different operators, you can actually do what's called, you can actually use and or, which is like show up in a lot of different languages with like two of the pipe things, or two of the ampersand signs. Instead, if you want to do and or in shell programming, you do -a or -o. So you can see test -w, the second argument that you pass in, and -r, the first argument that you pass in. Then you can actually run cat of $1, and greater is cat of $1 redirected into $2, or echo it. And now we're going to be talking about sort of the basics of how to program in the shell. And a lot of these basics are also correspond to the basics of programming in general. So like basically what I'm going to go over now is basically the basics of shell programming and kind of the basics of programming in general. And that'll answer someone who's asking about what does the phi do at the end of each statement. I'm going to go over that right now. So if-else statements are like the basics of almost all programming. That's like the basics of how do you do conditionals. So if-else statements are used when making statements which can be used to select an option from a given set of options. And Unix supports these if-else statements. So all of these if-else statements end with what's called fi or phi. It's basically just another way. You can think of it as saying finish, like this condition is finished. So there's three different types. There's if, fi, if else, fi, or if else if else fi, or just as many else's or else ifs as you want. So all of these always end with an fi, just to say that, okay, this conditional is finished, this conditional is over. But you can add else's and else ifs in between them to customize it to what you need. So if-fi statements are sort of the fundamental form of like a control statement, the fundamental form of a statement that lets you make decisions, and execute statements conditionally. And it's the fundamentals in almost all programming languages, saying if I want to move forward, move forward. If this value is greater than 0, then say that it's positive. If this condition, then do this. So if whatever expression you put in, then execute these statements if that expression is true, and then phi, just to say that it's finished. So let's say here you have A is equal to 10, B is equal to 10. If $A dash EQ $B, then echo A is equal to B, and then finish. So it says A is 10, B is 10. If the value of A is equal to the value of B, then echo A is equal to B. So A is equal to B. So when it goes to this conditional, it'll say, oh, 10 is equal to 10. So then the output of the program will be A is equal to B. And notice that it didn't use equal signs. It used dash EQ. That's important to know when you're dealing with integers. So just like in general, it'll say there's a test expression, and then if that test expression is true, it'll go to the body of the if statement. But if it's false, it'll go past it and go to the statements afterwards, after the phi. Next, we have if-else phi statements. So if-else phi statements are the next form of control statements, allow you to execute in a more controlled way and have decision making between two choices. And not just if something happens, then do it. Otherwise, just skip out of that whole thing. You do if this condition is true, if the number is even, then print it even. Else, say that it's odd. So if you can see if a number is even or odd. So the general syntax of this is if expression, then whatever statements you want to be executed. Else, if that expression is false, then have another set of expressions, and then phi to end it. So over here we have A is equal to 10, B is equal to 30. So you have A is equal to 10, B is equal to 30. 1 second. A is equal to 10, B is equal to 30. If A is equal to B, then echo A is equal to B. Else, echo A is not equal to B. And so when you run that program, the solution you get is 10 is obviously not equal to 30. So the program prints out A is not equal to B. So it checks whatever the if conditional is. If 10 is equal to 30, then end it and go into that statement. Else, go into the statement after that. And if you want even more like opportunities to like have conditionals, if you want even more conditionals on top of that, then you have if, else if, and then phi. If, else, and then phi statements, which are even more give you even more opportunities to like infinitely expanding if statements. So you have if expression 1, then the statements you want to do if that's true. Else if, so elif stands for ELIF stands for else if. So it's kind of like if this is true, then do this. Else if this is true, then do this. Else if both of these are not true, then do this. And then phi, obviously, at the end. So let's say you have another program here. We're just building off the same one. So A is equal to 10, B is equal to 30. If the value of A is equal to the value of B, then say that A is equal to B. Else, if A is greater than B, then echo A is greater than B. Else, echo none of the conditions were met, and then FI. So the solution to the program, so if we walk through this, is 10 equal to 30? No. So then go to the else if statement. Is 10 greater than 30? No. So then go all the way down to the last statement. None of the conditions were met. So there's no more else if statements. It just says else. So you just say, okay, none of the conditions were met, and the program prints out none of the conditions were met. So just like this diagram basically goes over that again. Like the if command, is it true? Then go to then phi. If it's false, then go to else if. If that's true, then phi, or if it's false, then else, and then phi. But let's say you have a lot of if statements. Let's say you want to check for, let's say the user inputs a number, and for every number from 1 to 10, you want to have a different thing show up. It's kind of inconvenient to write like an if statement for 1, and then an else if for 2, and an else if for 3, and else if for 4, and else if for 5, and else if for 6, and so on and so on and so on and so on. And that's going to be a lot of if statements, and it's hard to read your code, hard to look at your code and understand what's going on. So if you want a better way to deal with multiple if statements like that, then we have what's called a switch and a case. And in shell programming, the way you do switch cases is called case and ESAC. So it's kind of like a play on the word. So case, and then case backwards is ESAC. So that's sort of the reason that they did it. So it's convenient to remember, and it's also convenient to look at in code. So you can see like, oh, case, and case backwards. Just like, it's also the same thing they did with if statements. So if, it's also for finish, and it's also for like if backwards is phi. So a lot of things in shell programming go with that sort of syntax, where in order to end a conditional block, you just type what you used to start it backwards. Basically what a case lets you do is just you use multiple if statements to perform a multi-way branch. And that sounds kind of complicated, but it's really just a bunch of if statements combined into one. And so using multiple if statements at once, like I said before, where everything depends on one variable. If the user inputs a number from 1 to 10, and you should do something different for each number, then having multiple if statements is just inconvenient for doing that. But in that case, you should use case and ESAC statements to let you take care of the situation more efficiently. So the general syntax of how to actually type these out is you have case, word in, pattern 1, pattern 2, and then ESAC. So the operator word is case, and then you have whatever like command or whatever word or whatever number you want in, and then you start your cases. So pattern 1, parentheses, whatever statements you want to execute, and then 2 semicolons. And then pattern 2, whatever statements you want to execute in, 2 semicolons. And then you end with ESAC. So each one of these patterns and statements executed is basically just a separate if statement. And I'll explain it more when I actually show you like an example of how these work. So let's say you have a food that is soup, and the user can, let's say that maybe the user can enter any food, or you have the food hard coded in, and you want to do something different based on each one of the foods that could possibly be entered. So food equals soup. So you do case $food, so case of this, whatever this variable is, we're going to look at the value of that variable and do something different based on each one of what it is. So you do case $food in. So if the food is pizza, then echo print pizza pie is quite tasty, and then end that. Or if the food is pasta, then say, oh, I love pasta. But if the food is soup, then say soup is good for health, and then you end it with ESAC. So when you run that program, since the food is soup, it says, okay, we're looking at the variable here, food. So what is food? It's soup. Is soup pizza? No. Is soup pasta? No. Is soup soup? Yes. Then say soup is good for health and end it. So output is soup is good for health. And this sort of a diagram that goes over it like the if statement. So you look at case 1. Is case 1 true? Then you print the outcome of 1 and end it. Is it false? Then you check case 2. Is case 2 true? Then you do outcome of 2 and end it. Is case 2 false? Then you go on to the outcome 3 and go on so on and so forth and so on and so forth until you reach the outcome that you want. And now we're sort of past conditional statements, and we're going on into loops in shell scripting. So loops in shell scripting are basically like loops in all programming. So if you have some familiarity with programming before, then these loops are going to sort of come easy to you, and you should have to know the syntax. But if you don't have experience with programming before, then these loops are also going to be a pretty good introduction to general programming loops, along with loops for shell scripting. And the main loops we want to go over are while loops, for loops, and until loops. Each one of them has separate use cases and separate places where they're beneficial. So the first loop that we're going to go over is what's called a while loop. And a lot of these are sort of, the name is kind of explains it how the loop works. So the while loop enables you to execute a set of commands repeatedly until some condition occurs. It is usually used when you need to manipulate the value of a variable repeatedly. So what that means is the while loop lets you keep running a certain command or a certain set of commands while, so that's why it's called while loop, while some random condition is true. Whatever condition you want, while that condition is true, it'll keep running that command and keep running until that expression is ever false, if it ever is false. So the general syntax of it is while whatever expression you want, do the statements you want to execute, and then at the end you just put done, and that'll signify the end of the loop. So here's a sort of simple example of a while loop that uses in what this example is trying to do is display the numbers from 0 to 9. So instead of doing echo 0, echo 1, echo 2, echo 3, echo 4, echo 5, so on and so forth, you can actually use a while loop to do that. So let's say you have a is equal to 0, while $a, so while the value of a is less than 10, do echo a, and then a is equal to expr a plus 1. So this might seem a little complicated, but it's pretty simple when you break it down. So you're starting off with the value of 0. So a is 0. So you go into the while loop. Is 0 less than 10? Yes. So then you go to the do. Echo $a. So echo whatever value a is. So the first thing that it prints out is obviously 0. So a is 0, so it prints 0. And then it says, okay, now change the value of a. A is now equal to whatever a was before plus 1. So each time it's incrementing a by 1 and then done. So now a is 0, goes out, prints 0, and a is now equal to 0 plus 1. So a is now equal to 1, and it goes back to the top of the loop again. So loops aren't like if statements. They don't only run once. They keep running while that condition is true. So since a is now 1, 1 is less than 10. So then you print out 1. You see here it prints out 1. And now you say, okay, 1 is equal to, a is now equal to 1 plus 1. So a now you increase a by 1, and now it's 2. 2 is less than 10, print 2. Now print 2, and then now a is equal to 3. 3 is less than 10, print 3. Now it's 4. 4 is less than 10, print 4, now it's 5. 5 is less than 10, print 5, now it's 6. That's 7. Then it's 8. And then when it gets to 9, a is equal to 9. 9 is still less than 10. So then you echo 9, and it says, okay, a is now equal to 9 plus 1. A is now equal to 10. But when it goes back up, it says, oh, while a is less than 10. 10 is not less than 10, so it doesn't continue the loop anymore because the condition is no longer true. So it doesn't go into the while loop and ends at 9. So it prints out at the end, when you see the output, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it prints other numbers from 0 to 9. So that's basically the general way of how it works. You have whatever condition, while that condition is true, keep running, keep looping, and then eventually when that condition gets false, if it ever does get false, then end it. The next type of loop is what's called a for loop. And the for loop basically operates on list of items. So instead of operating on a single condition, it'll operate on a sort of list of items, and it repeats a set of commands for each item in a list. So while loops run based on just a condition, while for loops run sort of iterating over a list of items. It could be any list of items, and I'll show you an example of it below. And the basic syntax of it is for whatever variable in the list that you have, do the statements that you want to execute, done. So let's say you want let's say you have a loop where you're trying to go over a set of words. You could do for var in potato, tomato, salad, and chicken. then do echo var. Then it'll go through, okay, for each one of those things, so it goes potato, print echo potato, tomato, echo tomato, soup, echo soup. Well, I forgot what I said. Chicken, echo chicken. And it'll go iterate over each one of these things in the list and print that word. And then move on to the next one. It'll automatically move on to the next one in the list once this is done. So here's a simple example for loop to go through. So you have for var in 5, 6, 7, 8, 9. So your list of numbers is 5, 6, 7, 8, 9. And you're telling the program, okay, for this random variable var, it doesn't have to be called var, it can be called anything you want. In 5, 6, 7, 8, 9, do echo $var. So it says, okay, the first one in the list is 5. So echo 5. Then it automatically moves to the next item in the list, which is 6. It's like, okay, echo 6. Move on to 7, echo 7, move on to 8, echo 8, move on to 9, echo 9. And then it's like, okay, there's no more items in the list. The loop is done. And that's basically how it works. So just like this is another diagram for loops in general. So you start with x is equal to 0. Let's say you have for like var x in a certain list or something. Then you can actually loop through that list and do tasks based on how many there are left. And if it's no more left, then you end when there's nothing left in the list. So the next type of loop that we have is what's called an until loop. So an until loop is different than a while loop because a while loop is perfect for a situation where you need to execute a set of commands while a condition is true. But sometimes you need to execute a set of commands until a condition is true. So when you're starting off, the condition is not true yet, but you want to keep running commands until that condition is true. So the general syntax is until whatever command, do the statements need to be executed, and then done. So while loops run while a condition is true, but until loops run until a condition is true. And that's basically the difference between them. That's why they're used in different use cases. So a basic example of it is, actually, I don't know, just some more things about it. So if the resulting value is false, then the given statements are executed. So it only runs while that statement is false, while loops run while a statement is true. That's a big difference. This expression, it runs until that expression is false. It runs until that expression is true, but while loops run until that expression is false. So they're basically the opposites of each other. And so here's a simple example of how you would use that inside of the same way that you use the while loop. So let's say you have a is equal to 0. So you can do until not a is less than 10. So, or you can do until a is greater than 10. So saying while a is while a is less than 10. So until a is not greater than 10. So you're saying that until the value of a is greater than 10, keep running whatever is in this loop. So this is saying let's say you start off with a is equal to 0. So you say, is a greater than 10? A 0 is not greater than 10. So the statement is false, and you execute what's in the loop. So you echo a, so you echo 0, and you increment it. So I think this solution on the side is wrong. It should be the same thing as what was for the first while loop, where you had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be that as well. This one's off. But basically, it runs through the loop. So it says 0. Is 0 not less than 10? Is 0 not less than 10? But no, 0 is less than 10. So the statement is false. So print 0 and increment it by 1. Is 1 greater than 10? No. Is 2 greater than 10? No. Is 3 greater than 10? No. So on and so forth. You go to like 8. Is 8 greater than 10? No. Then the value of a is 9. Is 9 greater than 10? No. You print out 9. Then it increments by 1, so it's 10. Is 10 greater than 10? Yes. If the statement is true, then it ends the loop and it breaks out of it. So it's kind of like the opposite of a while loop. A while loop starts with a condition that's true and runs until it's false, but an until loop starts when a condition is false and runs until it's true. And then the final thing within like dealing with loops is what's called a break statement. So a break statement is used to terminate the execution of an entire loop. And after completing the execution of all the lines up to the break, it then stops the code and steps it down to the code following the end of the loop. So if you ever want to like just exit out of a loop instead of like letting the loop run through while the condition is true, you can actually just break out of it. So let's say you have a is equal to 0. While a is less than 10, do echo a, and then check, okay, is a equal to 5? Then go through the statement. But a is not equal to 5 yet. So you increment a by 1. So 0, so a is not equal to 0 plus 1, so it's equal to 1. Go up to the top. Is 1 less than 10? Then echo 1. Is 1 equal to 5? No. Then increase a by 1, so now it's 2. 2 less than 10? Yes. Echo 2. Is 2 equal to 5? No. Then 3. Is 3 equal to 5? No. Is 4 equal to 5? No. So then incremented by 1, so it's now 5. Go back to the top. 5 is less than 10. Echo 5. But now is 5 equal to 5? Yes. Then break. So it breaks out of the entire loop and stops printing anything else. So the solution of the program is only 0, 1, 2, 3, 4, 5, compared to before where it was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because you're breaking out of the loop once the value is equal to 5. Another thing that's important within coding in general and within shell programming especially is what's called arrays. So arrays are basically lists of numbers or lists of anything pretty much that can hold more than one variable. So when you're initializing arrays, you can initialize them in multiple ways. So you can initialize them based on like this sort of syntax, which if you've done like programming and stuff like Java or Python before, you're familiar with this. But if you're not, arrays have what's called variables and they have what's called indexes. They have like what's called elements and what's called indexes. So indexes start from 0. So you start counting from 0, and they're basically what number in that list is it. So if you have an array with two things in it, the first one is an index of 0, the second thing is an index of 1. So the first thing you do names of whatever index it is equal to mehar. So then you say names is the name of the array, and the first thing in that array is mehar. That's the first element. Then you do names 1 is equal to arsh. You could do it like that. Or you can initialize the entire array at once and say names is equal to mehar arsh. And that's the same, these two things do the same thing, but they're executed, but they're like sort of made in different ways. This one's done in one line, this one's done in separate lines. And then you could also just, if you set an array up, let's say you have names is equal to mehar arsh true and rishi, you can echo all of the things in names. So echo curly bracket names star curly bracket, and that'll print out everything in that array. If you want to do a specific element, let's say you want to get Druve. Druve is at the 0, 1, 2, the second index. It has an index of 2. So if you want to print out Druve, you do echo names square bracket 2, and then that'll print out Druve. If you want to do a Rishi, you do 3. If you want to do me, you do 0. If you want to do Arsh, you do 1, and so on and so forth. So it's ways of holding more than one variable in shell programming and in programming in general. Another really important thing, like this is just the basic functionality of it, but functions are basically what all of programming is built on. It's built on making functions to do things for you. So functions enable you to break down the overall functionality of a script into smaller logical subsections, which can then be called to perform their individual tasks when it's needed. So basically, let's say you have a certain piece of code for printing out a statement in in a really well formatted way, and you have that sort of formatted printing and you have that formatted printing out in and you have to call that formatted printing like a bunch of times. Like every single time you add a new variable, you have to print it out in a really nicely formatted way. Instead of sort of instead of putting that code like over and over and over again and just copy pasting it over and over again in your code, what you can do is you can make a function for that and just call that function so that you can actually break down the different pieces of your code, different functions. So you can avoid like pasting the same thing over and over again. So the general syntax of how to make a function is you do the function name, then open parentheses, close parentheses, and then you surround whatever list of commands you need in curly braces. So it's kind of similar to the way you do it in, let's say, like Java or something. So let's say you have a function called hello. Then in that function, all it does is it echoes hello world. It echoes hello world $1. And then you want to call that function. If you want to call that function, the syntax of calling it is the function name, so hello, and then any sort of parameters needs to be sent in. So this one takes in one parameter. Let's say it's your name. So you want to call it hello world Mayhar. You do hello, the name of the function, dollar, curly bracket, and then my name in there, and then end curly bracket. And that'll basically call that function, passing in my name as $1, the first argument. And there's so much you can do with this in terms of like making functions do whatever you want, breaking down your code. But the basic functionality of a function is you take an input X, or you take in no input at all. The functions don't even need input. They can just do things on their own. And then you put an input, run it through a function, and output it. So you can put a function to square items. So you can say square $4, and it'll return 16. Or you could do a function for multiplying two numbers, and you could do a function for finding the square root of a number. You can do so much more with functions that let you make your code more readable, more efficient, and improve the overall functionality of it. Another really important thing with shell programming, something that you're going to come up with often, is let's say you want to actually read what the user inputs in as part of your shell script. So let's say you don't want to put you don't want to hard code whatever number you want in. Let's say you want to make a piece of code that can square a number. Instead of just having you code in the number, you can have the user input the number and actually print out the square of whatever number they input in. So you can get the input of the user as part of the shell script and act upon it. And that's done by using the read statement. So let's say this is an example program. So you have echo, how are you? And this is just like an open operator. And you do read status. So what this does is it prints out to the console, okay, how are you? And then puts like a new line. And then you have this read command, read status. So status doesn't exist, but what it does is whatever you type in next, it'll assign that to the variable called status. So it'll make a new variable called status and assign its value to whatever you type into the command prompt. So let's say the program prints out how are you? You type in happy. Then it'll read that in, and then in the next statement it says echo I am $status. It'll say I am happy because you inputted happy, and it read happy and assigned status, the variable, assigned the value of happy to the status variable, and now you're printing that out. So you can actually read user inputs and do a lot more with this. This is just like a really, really simple way of doing it, of using it. You can use it to make like functions that take in user input and like act upon it. You can do like functions that like have like moving parts in it, and there's so much more you can do if you combine all the things we talked about. And that's basically like the foundations of programming too, is taking in user input or taking in different variables and making functions or loops or other characteristics to create like really, really powerful tools in the shell or in any programming language. And the final thing we're going to be talking about is basically the debugging shell. So the debugging shell is basically just a way to debug your shell procedures. So there's a lot of shell procedures. There's obviously going to be like errors and stuff that show up. So like the sh command lets you like debug or run these like it executes commands run from these terminals, and it lets you run these like commands, these scripts from their file names. And the -v and the -x let you what's called what's called a verbose option. So the verbose option is what you use for debugging, which basically tells you it prints the commands before it executes them. So it gives you a lot more information about, okay, when you run this program, let's say you sh-v, you have a test script called like, I don't know, squaring function, and you do sh-v or sh-x, what it'll do is it first of all runs that script, but it also tells you a lot more about what was going on in the back end, like what was going on when you actually ran that script and what like happened, what went wrong, and stuff like that. And so it's basically a useful way to debug it beyond just the normal way of debugging, which is like going through your code and realizing like what you did or any errors you had. And I think that wraps it up for today. So I just want to go over just the basics of shell programming, shell functionality, and also introduce you to some of the basics of programming in general. Which are going to be, there's going to be a lot more webinars coming up about like general programming Java, programming Python, and the foundations of those. But I just want to give you a little bit of an introduction, a little bit of a taste of how that works, especially when it comes to shell, because believe it or not, the shell is actually used a lot, even today. Like the command prompt Unix, they're used in almost every company, every single area uses Unix in some form or the other, on top of whatever other programming languages they use. So it's a pretty powerful tool to know. And if you're able to make functions and scripts and shell procedures with that, it's going to help you a lot in the long run. So as always, this presentation and this recording is going to be shared with you soon, along with, I plan on getting like a sort of a practice out that uses some of these commands, that lets you like play around with some of these commands and sort of in like a lab type format that lets you like go in and actually start playing around with this. I'm trying to figure out how to make that, how to work that out. So you can actually, the best way to actually learn these commands, how to make these functions, is obviously to just do it and make them on your own and play around with it. So I'm trying to work on in the next few days to see if I can get that out to you. But the recording and the presentation, I'll get that out to you as soon as I can. And if you guys have any questions for this webinar specifically, just like all the other ones, there's a specific email you can send to it called unix@hsnavigator.org. So if you have any questions about the webinar or any questions about Unix in general, based on the slides that we have, that you can send it to unix@hsnavigator.org. And besides that, I think that's just about all I have for this. After this, we have, I believe it's the data analysis presentation, which is going to be really interesting. So once you guys are done here and you're ready, then you can move on to the data analysis presentation, and that will hopefully be starting at around 1 o'clock. So there's still going to be a few minutes. You can take a little bit of a break, like stand up, stretch, get some water, and then if you want, move on to the data analysis presentation coming up soon. So I'm going to end that webinar here, and I'll see you guys. Actually, I guess I'll see you guys next week, because the next presentation is not going to be